Welcome to the DIY Honda Garage channel. The DTC P0141 refers to a specific issue with the secondary heated oxygen sensor, HO2S, circuit for your Honda CRV 2011 to 2016 model. This particular code indicates a malfunction within the heating circuit of the secondary HO2S, which is essential for ensuring efficient catalytic converter operation. When the engine is running, the secondary HO2S helps monitor exhaust gases after they pass through the catalytic converter, allowing for optimal performance of the vehicle's emissions control system. The secondary HO2S is located in the exhaust system, usually downstream from the catalytic converter, making it a critical component in ensuring that emissions meet required standards. The diagnostic trouble code, DTC, is confirmed through the engine's computer system, and troubleshooting must be done carefully to locate the specific malfunction, either in the sensor itself or in the wiring associated with it. The secondary HO2S plays a vital role in assessing the efficiency and functionality of the catalytic converter. This component assists the engine control module, ECM, by providing feedback on exhaust gases, ensuring they are within the optimal range for clean emissions. The sensor is located downstream of the catalytic converter, which enables it to measure exhaust composition accurately after treatment. If this sensor fails, it could lead to poor fuel economy, increased emissions, and potentially failing an emissions test. Therefore, understanding the role of the secondary HO2S is crucial for diagnostics, as it directly affects performance and environmental compliance. Furthermore, any issues related to the heater circuit can cause erroneous readings, complicating overall vehicle health. Several factors may lead to a DTC P0141 under Honda's diagnostic guidelines. A shorted circuit could occur in the wiring harness associated with the secondary HO2S, disrupting the flow of electricity to the sensor's heater. This short can often be caused by frayed wires or improper connections, leading to the malfunction indicated by the DTC. Alternatively, the secondary HO2S itself may simply fail due to internal damage or degradation over time, necessitating replacement. Open connections may also contribute to the heater circuit failure, where the wire is disconnected or damaged between the sensor and the engine control module, ECM. Comprehensive checks of both the wiring and the sensor are necessary for proper diagnostics. When experiencing issues related to DTC P0141, several symptoms may be noticeable. The most immediate and obvious indication is the illumination of the check engine light on the dashboard. This alert serves as a warning that there is an issue that requires attention. Additionally, the vehicle may exhibit increased emissions, which can impact compliance with environmental standards and may also lead to a failed emissions test. Poor fuel economy is another symptom that might arise due to the engine running inefficiently without proper feedback from the sensor. If drivers notice these symptoms, they should not only record the DTC, but also take steps to troubleshoot the issue before it leads to more severe engine performance issues. The first step in troubleshooting DTC P0141 involves verifying the problem through a series of systematic checks. To begin, turn the ignition switch to the on position, which powers the vehicle's electrical system without starting the engine. Following this, clear the DTC using a Honda Diagnostic System HDS tool, which allows mechanics to reset any stored fault codes. After clearing the codes, start the engine and allow it to idle while monitoring for any immediate DTCs, confirming whether P0141 has reappeared as a pending or confirmed code. This first step is essential for establishing a baseline for further diagnostics, helping to identify whether the issue is persistent or transient within the system. In the second step of troubleshooting for DTC P0141, the focus shifts to examining the electrical supply to the secondary HO2S. Begin by turning the ignition switch to the lock position, ensuring all electrical currents are halted before conducting the assessment. Next, locate and check fuse number B2, which regulates power to the secondary HO2S heater circuit. This fuse is found in the under-dash fuse relay box, and a blown fuse indicates a short circuit in the IG1 ACG wire. If the fuse checks out as functional, this confirms that the wire between the secondary HO2S and the B2 fuse does not exhibit any shorts, allowing you to proceed with further diagnostics. The third troubleshooting step requires a more hands-on approach with the secondary HO2S component. Begin by disconnecting the 4P connector of the secondary HO2S, allowing for a direct measurement of the sensor's internal resistance. Using an ohm meter, measure the resistance between the specified test points on the connector, which must be conducted with the ignition in the lock position. At room temperature, the resistance should fall within the range of 5.4 to 7.3 ohms, signifying that the sensor's heater circuit is functional. If the readings deviate from this range, it is indicative of a faulty heater element, necessitating replacement of the secondary HO2S to rectify the issue and restore proper operation. In this step, the focus is on assessing the internal circuit of the secondary HO2S to confirm its operational status. With the connector still disconnected, check for continuity between the designated test points while ensuring the ignition remains in the lock position. This test verifies whether the internal connections of the secondary HO2S are intact and correctly functioning. If continuity is present, this confirms that the internal circuitry of the sensor is operational, indicating it is functioning correctly. However, if continuity fails, there is likely a fault within the sensor itself, calling for its replacement to prevent further issues in the vehicle's emission system. Step 5 involves evaluating the voltage levels present in the circuit connected to the secondary HO2S. Turn the ignition switch to the on position to begin this diagnostic step and measure the voltage between the specified test points while ensuring the 4P connector remains disconnected. This check will determine whether there is appropriate battery voltage supplied to the sensor's heater circuit. If battery voltage is present, it indicates that the power supply to the secondary HO2S is intact, and attention should then be directed to the vehicle's wiring. Conversely, if there is no voltage detected, it suggests an issue within the wiring, necessitating further diagnostics to locate and rectify any breaks or shorts in the circuit. The sixth step involves ensuring the integrity of the SO2HT wire, which plays an important role in the secondary HO2S's function. Begin by turning the ignition switch to the lock position and jump the SCS line using the HDS to prevent any system errors during the diagnosis. After this, disconnect the PCM connector B, which allows for a more accurate continuity check between the secondary HO2S and the engine control module, ECM. Measure the continuity, ensuring that the wire does not exhibit breaks or faults between the connections. If there is continuity, it implies the wire is functioning properly. However, if the continuity test fails, repairs will be necessary to restore proper function within the SO2HT line. In troubleshooting step 7, the objective is to ascertain whether the IG1 ACG wire has any open circuits affecting its performance. Turn the ignition switch to the on position, ensuring the vehicle's electrical systems have power. Then, measure the voltage between the designated test points while keeping the secondary HO2S connector disconnected. If battery voltage is present, it confirms that the IG1 ACG wire is not experiencing any open circuits. However, if there is no voltage detected, it indicates a break in the wire between the fuse number B2 and the secondary HO2S, necessitating immediate repairs to restore electrical continuity and allow the heater circuit to function correctly. The final troubleshooting step focuses on the continuity of the SO2HT line to finalize diagnostics of DTC P0141. Begin by putting the ignition switch in the lock position and jumping the SCS line to protect the vehicle's electronic systems. Disconnect the PCM connector B before checking for continuity between the appropriate test points on the SO2HT wire. If continuity is confirmed, it suggests that the wiring is intact, and any issues may stem from the PCM itself. Should the test show an open circuit, necessary repairs should be made to the SO2HT wire between the secondary HO2S and the PCM to ensure that proper electrical signals are reaching the sensor. Update the PCM software if needed, or consider replacing it if continuity fails despite all checks passed. After completing all necessary repairs pertaining to DTC P0141, the final step is verifying that the repairs have resolved the issue effectively. Begin by turning the ignition switch to the lock position and ensuring all connectors are securely reconnected. Next, power the vehicle back on by turning the ignition to the on position and use an HDS to reset the PCM and perform the idle learn procedure as required. Monitor the onboard diagnostics (OBD) system for the status of DTC P0141 while observing whether it indicates passed, failed, or not completed. Confirming the pass status verifies that repairs were successful and the system is functioning properly. If faults persist, revisit earlier steps to ensure thorough checks were conducted, ensuring a reliable resolution. To help prevent future occurrences of DTC P0141 and ensure your vehicle's emission system remains healthy, it's essential to perform regular maintenance. One key aspect is routinely checking electrical connections related to the secondary HO2S, looking for any signs of corrosion, looseness, or damage. Also, inspect wiring for wear and tear, particularly in areas that may be exposed to heat or continuous movement, which can contribute to wiring failures over time. Promptly replacing any faulty components ensures optimal performance and compliance with environmental regulations. By embracing these preventive measures, vehicle owners can extend the lifespan of their emission systems while avoiding costly repairs down the line. In conclusion, addressing DTC P0141 requires a thoughtful and systematic approach to diagnostics, focusing on the secondary HO2S and its associated circuits. The secondary HO2S sensor is crucial for monitoring emissions and ensuring the catalytic converter functions correctly, thus aiding in achieving environmental compliance. Understanding its connections, grounding, and the role of components such as the PCM is vital. Conducting thorough diagnostic checks can reveal underlying issues that, if left unresolved, could impact vehicle performance and emissions. By addressing faults quickly and adopting preventive maintenance strategies, vehicle owners can enjoy smoother performance and avoid future disruptions related to the emissions control system. Please like and subscribe to the channel. See you next time.